This is question 6 from paper 1-3 from the June 2020 exams from Cambridge International Education. In the description below this video, you'll find a link to an image of this question so you can try it before looking at my solutions. This question is all about rates of change, and in the question they give us this curve. You don't need to know what this looks like, but you can put it into a graphing calculator if you're studying at home and find it looks something like this. Now I'll just draw it because I'd like to talk a little about what is happening. So the question, they tell us that a point is moving along a curve. So this is still x, y. There's no time on this picture, but there is a point, let's say it's here, and it's moving along. Something like that. So when time passes, it moves along. And they tell us a little bit about it. They tell us that it has a constant rate of change in the x-axis, and it's equal to 2. So that means if I were to draw a point here, you could think of it had two shadows. One shadow is down here and one shadow is here. As the point moves, this dot here moves. So what they're telling us is this rate of change is actually equal to 2. Or you can think of it more of its speed. Its speed is a constant, just 2. Just constantly moving along. But the maths way to write that, what they told us is dx dt. When time passes, how much does x change? And they tell us that's a constant of 2. So that's really what they told us there. Now then they're going to ask us a question about find the rate of change of the y-coordinate when x is equal to 2. X is equal to 1. So what they're asking about there is the rate of change of the y-coordinate when, and that's what this means, when x equals 1. So that's what they're really asking us to find. And you can imagine that in this picture, as x constantly changes here, so as it moves here, it's actually going to go up really fast here. Like the shadow on the y-axis go really fast here. But as x is moving here, or as the dot is moving and x is constant, y is actually going to go up really slowly here. So this is not going to be a constant number. Now really, none of that is necessary to answer the question. What you need to answer the question is you need to remember your chain rule. So there's a few things we know. We have y, so we should be able to find dy dx. That's something we should be able to find. They give us dx dt. They give us dx dt. And the chain rule tells us when we have two things like this, you can think of it like these are cancelling. It's a little dangerous when you move into higher level maths in college. But you can think of it like this for the moment. What you get is dy dt. And that is what they're looking for. So we actually have everything we need to answer this question. So first, let us try and get dy dx, because that's what most of the marks in this question are. That's what the examiner thinks is going to challenge you in this question. So dy dx is equal to, and we use the chain rule whenever we have a bracket like this. Pretend the bracket is just a simple x. So how do we differentiate x to the power of a half? The half comes down, we multiply by whatever is in the bracket. I'm saying pretending it's an x for the moment, and this we lose one number here. So a half minus 1 is minus a half. Now we're not allowed to quite do that, so let's not put x in here. Let's just put what was here, 5x minus 1. That's the chain rule, with one exception. We cheated. We cheated in this bracket. So let's fix that little mistake we made. We differentiate what's in the bracket and multiply. So let's differentiate just what's in the bracket. So we have 5x minus 1. The derivative of 5x is just 5. Let's multiply it here. 5, and the derivative of minus 1 is nothing. So we just multiply by 5. We could just write that above here. Let me actually clear that away, and we'll just put the 5 here. So that is the derivative of y with respect to x. We already know dx dt is always 2 at all points. So I can now already write dy dt. It's equal to this guy, 5 over 2, 5x minus 1 to the power of minus a half, multiplied by this guy, dx dt, or just 2. So I can put the 2 here, or let's put it over here, because it'll cancel quite nicely with that 2. So that's it, that's dy dt. Remember, that's what they asked us for, nearly, but they told us x is equal to 1. So let's do that here. dy, I just have some bumps on my board, so I'll move over a little. dx dt when x is equal to 1. And that is equal, let's see, 5 is here. I'm just going to write this out again, but instead of x, I'm going to put a 1. 5 multiplied by 5 by 1 is 5. 5 minus 1 is 4. 4 to the power of minus a half. If you're not sure, if you're a little unsure how to do powers and minuses, a calculator will do all this right now. It's all just numbers. But this is equal to 5 times 2 to the minus 1. So we could get to the power of a half first, and then we'll do minus 1 later. Again, this is just equal to 5 over 2. That's all minus 1 does, brings it up or down the denominator. So 5 over 2 is the answer to part A. Part B, I think I have enough room to do it here. Part B asks us to find the value of x when the y coordinate is increasing at 5 over 8. So they're saying when y coordinate is increasing, that's with respect to time, because they give us units per minute. So that's units per minute. So this is equal to 5 over 8. What is x? Well, dy dt, I know what dy dt is. Here it is written right here. So instead of dy dt, let's write 5 times 5x minus 1 to the power of minus a half must equal 5 over 8. Can I solve this? Hopefully in this much room. I've left myself a little shorter room, so I must apologise for that. First thing I'll do is just cancel the 5s. Leaves 1 there. Divide both sides by 5, basically, is what I did. And next thing, let's take both sides to the power of minus 1. So basically multiply this by minus 1 and take all this to the power of minus 1. So that just becomes 5x minus 1 to the power of a half, and I flip this upside down, 8 over 1. I took the inverse of both sides. The other thing you could think of is maybe I just moved them across the equals. Both came up. The 8 came up this side. And remember, the minus means it's below the denominator. Came up this side. I could probably explain that a little better, but I'm running out of room. And you know what? This is I'll let you ask a question about this in the comments if you need clarification. All right, let's square both sides. Let's get 5x minus 1 is equal to 64. Let's add 1 to both sides. That disappears, equals 65. And that means x is equal, divide both sides by 5. X is equal to 30. And that's the correct answer, I believe. Yeah, that's what I got earlier to part B. So hopefully that answers everything. Like I already said, if you have more questions, put them in the comments below, and I'll happily try and clarify anything. Thanks for watching and have a great day.